Okay. Yeah, so the questions come in. We'll look at the seating chart here. So what I did was I went through those results on the poll, and everyone who said they wanted to get in-person classes, I put you into two groups so that this week group one could say meet Monday and Friday. Group two meets Wednesday, and then next week group two will be meeting Monday and Friday, right? So it's going to have to alternate because there just wasn't enough, there weren't a small enough group where I could have you in here all twice a week, right? Now that might change moving forward. I've gotten so many emails about people having to quarantine, which off the bat, I'm sorry if my emails to those sound short or they sound like dismissive. I'm not meaning to be at all. I'm just getting, several every day. And, let me know if that is the case. And I'm not trying to be dismissive of it. I'm just trying to get out emails real quick to respond to you. I can already see here today, even though there are these groups and everyone in these groups said that they wanted to show the in-person classes, we still have quite a few empty seats today. And so the issue is going to be that these are coming in quicker than I can cross-reference them. So I'll sit down tomorrow and I'll try to cross-reference with all the emails I've gotten about who has to quarantine, and maybe, try to create some type of a system where you can sign up for certain days, because even these groups, there's so many people in these groups who, even though they want to be in person, aren't able to right now, right? But these were just reflecting what it would be like if no one had to quarantine. These are all the people that wanted to show up, and so that's why I created groups that way, right? If I can think of a better way to deal with the quarantining and overlapping of different quarantines, I will, but I don't have a system for that yet. So for right now, these are all the people you responded that you want to be in-person classes. These are the two groups, and they'll alternate each week. So group one, you'll only be meeting once next week. Group two, you'll be meeting twice. Okay? Any other questions on that? Yeah, and if you want to move to a different day, send me an email, and I can try to cross-reference and see if there'll be someone who has to quarantine, and maybe I can let you know if that's possible. Okay? All right. So we left off last class doing some Excel work. So if we look at the slides here, we built these frequency tables. We built these relative frequency tables from the relative frequencies that we created. We could do something like this. We could do relative frequencies and make a line graph instead of a bar graph. That's not much more difficult. I'll show you how we can do that here in just a second. And then what we're going to talk about today is cumulative frequencies, and that's the Excel work we're going to do today. So I'm going to start up by pulling up that blank file. Now, if I wanted to create a graph, and actually told you guys to yell at me if I forget to do this. All right, so you can see it a little bit better. If I wanted to graph my relative frequencies that we left off of last class, I don't remember if I show you. All we have to do, select the labels, hold control and select your relative frequencies, or hold control or command on the Mac and select your relative frequencies. We would then go to insert. There's all these chart options. So we could just make it a bar graph, but we could, there we go. We could also just do this line graph. It still shows us the same information. It shows us that the bin that has the highest relative frequency is this first one, and that the other ones are relatively quite a bit smaller. Either one's fine. And on a homework or something, I'll explicitly let you know. To be honest, in any of the homeworks, we shouldn't be doing any of these. They should all be, I believe, bar graphs. We'll be asking you for bar graphs. But the process isn't any different, right? I just insert and I select the kind of chart I want. So with these relative frequencies, the next thing we're going to do, and this isn't in the complete file, I'm going to show you an intermediate step, okay? So I think in the completed file, here I've got cumulative relative frequency. But I think just for the sake of what we're talking about, it'll make a little bit more sense if we start out with just the cumulative frequencies, not cumulative relative frequencies. So we'll actually add in both those columns right now. So what we're doing cumulative frequencies, think about it this way. If I'm calculating your GPA, you have a GPA for this semester, but you also have your cumulative GPA, which looks at your semester this semester and goes all the way back to every semester before it as well. So that's really what we're doing with cumulative frequencies. We're going to look at the frequency of the bin that we're looking at plus every bin below it, right? So instead of like with GPA, it's before, now it's below or less than, right? So for this very first bin, the cumulative frequency, it'll be the frequency of this bin plus every bin below it, but there's no bins below it, right? So this one's actually pretty easy. It's just the same as the frequency, right? But now for the next bin, remember the cumulative frequency is the frequency of the bin that we're looking at plus every bin below it. So we would actually take that 36, or sorry, that 7 and add 36 to it, right? Or we could use, that sum function, right? Now the problem with doing this is, okay, well this bin, I would take the frequency for this bin, add up the frequencies below it, so now there's 2 below it, so I could go equal sum, add these, right? And I can keep on doing that all the way down to the very last bin, right? But another way I could do this is, delete this real quick so I can show you. If I say to find the cumulative frequency, we take the frequency of the bin we're looking at plus every bin below it. Well, the cumulative frequency of the previous bin would give me the frequency of every bin below it. So what I could do is say, take the frequency of the bin I'm looking at and add to it, I'm going to do this, I can't quite select it. There you go. And add to it the cumulative frequency from the bin below it, right? Oh, Q7 here. Right? Now when I copy this down, it keeps working for me. It takes the frequency of the bin I'm looking at and adds to it the cumulative frequency from the bin prior to it. Right? Now once I get down to the very last bin, I should have a cumulative frequency that's equal to my total number of observations. Why? Well, because if I say I'm going to count up the number of observations from this bin and every bin below it, well, that's every single observation, right? So I should be getting a cumulative frequency for that final bin that's equal to the total number of observations. Right? I can do the exact same thing for cumulative relative frequencies. Instead of adding up the frequencies, I'll just be adding up the relative frequencies, right? So I have that in the completed file another way. But if I have my cumulative frequencies first, how do I get relative frequencies? It's the same if we're doing cumulative or not. If I have the cumulative frequencies, I can just divide by the total number of observations, right? Just like before, we're creating relative frequencies from frequencies. To get cumulative relative frequencies from a cumulative frequency, you just divide by the total number of observations. Now, what else do I need to do here before I copy it down? Yeah, I want that 52, that cell reference not to change, so I have to throw dollar signs in there, right? But now, should be good to go. And what should the cumulative relative frequency for that last bin be? Yeah, I see someone holding the finger up 1, right? And because once I get here, that's every single observation, right? I'm going to switch here real quick to give you another way to think about these cumulative relative frequencies. But before I do that, thought about one more thing. We can also graph these really easily, right? It's the same way that we graphed things before. We select the labels, select my cumulative relative frequencies. With these, quite often, we would show the cumulative relative frequencies in a line graph, something like this. This is actually in the slides. You insert these graphs always the same way. You just select that data, you select the labels and select the data that you want, and then insert whatever type of graph you want, a line graph, a bar graph, okay? Let's see if there's any questions. All right, so I'm going to switch here. Hopefully this works. Okay. I think I'm frozen right now for those of you on Zoom. But if I get confirmation here in just a second that you're able to see paper in my hand. All right, awesome. Thank you. Let's zoom in a little bit here. Okay. So let's say I've got something like this, right? And I've got my frequencies up here. Okay. And I'm not going to write in every single bin, but just the first three. But the same process would kind of apply if we kept moving forward. I'm going to move this out. Okay. So let's say, and I don't know if I'm going to get these numbers exactly right, but it should be okay. As long as we have some numbers to work with, right? And I think this was like 5 or something. Right? So we had our original frequency distribution, right? Another way to think about this, how do we create cumulative relative frequencies or cumulative frequencies? If we have the exact same categories down here, but now we want the cumulative frequencies. Well, we said for the first bin, that's pretty easy, right? Because there's nothing below it. So for this first bin, the cumulative frequency would be 36. That one's pretty easy. Well, now for the next one, we would take the frequency of this bin plus every single bin below it. So 7, add that to the 36. Right? So that's what? 43. Now for this one, we would take the frequency of this bin plus the 2 bins below it. Right? So if we do that, we get what? 5 plus 7 plus 36. So we get what? 48. But you can almost think about it this way, right? What is in this? So this one's pretty easy. The cumulative frequency was the same here. But on this next one, right? Here was like the second bin, the frequency of 7, and this came from the first bin. So when I wanted to find the cumulative frequency of this third lowest bin, I took 5, added 7, and 36. Well, if I take that same 5, notice in here is that 7 and that 36. So in Excel, when I said what we could do is just take the frequency of the bin you're looking at and add to it the cumulative frequency from the bin below it, that's the reason why. Because that cumulative frequency from the previous bin was already the sum of all the bins below that one we're currently looking at. Okay? That's just kind of another visual way to see this. Hopefully on Zoom, if I'm writing something out, I know it's a little bit, if it looks a little bit smaller, you can't quite make out something I wrote down. Make sure you ask either verbally or type something in the chat if you need some clarification. Also, if you are following along with me, I'm usually saying a lot of what I'm writing too in terms of like the words and the numbers, so that might make it a little bit easier as well. Okay. All right. So we're going to switch back here. And we're going to go back here. So hopefully we're having troubles in class, in-person class. Give me 1 second. Switch back up. All right, there we go. So we left off. Now we've got those cumulative frequencies kind of done. The next thing that I want to show you is actually going to be something that we have in the completed file. So we've been working with this blank file to kind of get some practice following along with this. Here's the completed file. I'm going to show you a couple other things. It's really easy, really simple now that we've talked through everything else. But let's say I had this life expectancy data where I've got healthcare expenditures by country and life expectancy. I might want to know how are these things related, right? Or what's the relationship between these? Maybe as countries spend more on their health, their life expectancy goes up, or is it that they're spending a bunch of money on their health because they're not healthy, so their life expectancy might be lower, right? Well, we have these things called scatter plots. So I'm going to grab the data here, go to Insert, and there's this little scatter plot option, right? Select that first one, and it automatically kind of plots whatever the first variable on the left the first variable I selected was, that becomes my x-axis. Whatever I select as a second variable becomes my y-axis, right? And then I have every single one of these countries plotted on this scatter plot, right? If I then tried to draw a line that kind of best fit all this data, it would kind of look like, maybe there's a slight positive relationship here, right? Kind of gives me a quick visual of how are these two variables related by plotting all of my data points, okay? And that was as simple as selecting the data and inserting that scatter plot. Now I think you can play around with like adding, we do it this way. Notice if I select these and it kind of put some of those labels in there, I can go and play around with axes, titles, and stuff like that. Like I said, I'm not really concerned too much with the formatting for this class. It's more I just want to make sure you know how to get that data into that scatter plot. We also have this time series graph. I made this up in my earlier section, so I'll delete this real quick. So we have this unemployment rate across the years. We wanted to create a time series chart that was just simply, we'll select the name too, insert a line graph. We've now got the unemployment rate. The only issue is we need years as our x-axis. So how do we do that? We click on those numbers, kind of see now they're selected. You then right click, go to select data. There's this horizontal axis labels. So instead of 1, 2, 3, we want 2005, 2006. So we hit edit and then just select the years that we have in the data, right? Hit OK, hit OK. Now we can kind of tell a really quick story. So time series graphs are pretty easy to create. They convey a lot of information pretty quickly, right? I can say, well, look, I basically can just walk through and tell a story. Mid-2000s, unemployment rate was pretty stable, right around 5%. It increased in 2008, 2009. It began to decline in 2010, and has really declined ever since, with the exception of this year, it spiked up a lot, right? So obviously, because of COVID, not a lot of people aren't working. And so we can quickly see like, man, something happened here and something happened here. So this was the recession, and now here, this is COVID, right? So another nice thing, if I have multiple countries or something, so that's where, and I'll go back here since I have the made up data. Let's say I made up some Canadian data. The way I get this graph is the exact same. I just highlight this, insert a line graph. It automatically puts both those countries on there. I would then have to, select these, add in my years. But now I can like compare pretty easily two different groups, or here are two different countries' unemployment rates. Okay? Any questions on any of that before I keep moving here? No? All right. So that should be our Excel work for today. Talk about these cumulative frequencies. I walked you through this, but here's just kind of a reminder of the steps that you would take to create a scatter plot. Also, just to kind of look at the data a little bit, this is kind of interesting, right? It looks like there's a positive relationship, with the exception of the United States, who we spend by far and away the most, but our life expectancy for these, at least these countries, right, is actually the second lowest. Here's the unemployment rate, step by step how we did that. I already walked us through that. And now we'll kind of lead into some different discussions. So I'm going to show you 4 different types of distributions, right? And then we're going to talk a little bit about some other statistics that we can calculate for data sets that give us some information about them. So the first one, and we're going to see this a lot this semester, is a normal distribution, right? So a normal distribution looks like it's symmetric, or that there's, if I kind of had to draw a line in the middle, the left side would look very similar to the right. Now, no distribution will be perfect, but if we created this histogram, and this is, I think, for average SAT score data by school, if I try to draw a line that kind of best fits all these bars, I'm going to end up with kind of this normal or this bell curve, right? And we'll work a lot with this semester, okay? We also might see a distribution that looks something like this, where it has a really long right tail. This is income data. So you can kind of imagine the majority of people are making like lower amounts, and then you have very small number of people up here in the higher categories, right? So if we have a long right tail, we're going to call that right skewed data. And we'll talk about, really, that's a good way to remember it, but we'll talk about some other characteristics of right skewed data We probably won't get there today, but on Wednesday, we'll actually start the discussion of another reason, or the real reasoning why this is called right skewed data. But for now, long right tail, right skewed, okay? Here we've got the length of a pregnancy or weeks of gestation, right? We've got a long left tail, so we call this left skewed, right? So it kind of makes sense. We don't see babies being born at like 11 months, but we see premature babies being born at 5, right? So this long left tail here. We then also have, sometimes, here we've got body weight. We call this bimodal. So it almost looks like there's like 2 normal distributions here, right? We would call that bimodal. What do you think is probably driving that here? If we were to record body weight, why might it look like there's 2 different normal distributions? What's something about someone, like, parsed it out? Yeah. Well, yeah, right. If I separated all the observations by male and female, here's my male distribution, here's my female distribution, right? So there's obviously going to be some overlap, but if I have a characteristic where the averages are a lot different because of that, then I'm going to end up with what looks like a bimodal distribution, right? Yeah. It could be if I had, yeah, it depends on what my data looks like, right? It doesn't have to be gender. I think that's what it is here, but it's a characteristic that is, if I separated the data by that characteristic, I would have distinctly different averages, right? So yeah, you had age, like maybe we had like income and age or something, and we had a lot of really old people in the data set and a lot of really young, we might see something that looks similar to that as well. Yep. All right, that's good. So the next thing we're going to do is think about how do we calculate a couple other statistics about the data that tell us some things about. So the very first thing we're going to do, looking at population and sample data, is we're going to find measures of central tendency. So these measures of central tendency are trying to tell us, look, we've got all these observations, but if I try to kind of find where the middle values of those observations are, what would those measures of central tendency be? Where are the middle kind of values, right? So we'll have three characteristics, 3 statistics: the mean, the median, and the mode, right? So the way that we're going to notate things in this class is anytime we're looking at a statistic where it's a population statistic, so it's from population data, we're going to use Greek letters, right? And I'd say we, everyone, this is kind of normal convention, but so here mu is going to be our population mean, and then X bar is going to represent our sample mean. So our sample statistics will be using our standard English letters, right? For the median and the mode, we're just going to use capital M subscript D for the median, capital M subscript O for the mode. Okay? Now, if I wanted to do sample, median, and modes, we would just write lowercase m's in here. So that one's a little bit easier to remember. We're not going to do much, there's no differences there, and so that's why I didn't put them up there. But for the mean, we will write the sample mean as X bar and the population mean using this Greek letter mean. Okay? We're also going to do measures of variation. We won't get to like how we calculate these today, but starting Wednesday, we'll do some, we'll go through this. And so we're going to find the variance and the standard deviation. The variance, population variance, we write as sigma squared. That's that Greek letter sigma. For the sample variance, we're going to use S squared. And then the standard deviation is just the square root of the variance. We'll talk about that more Wednesday as well. But to represent the standard deviation, we'll use sigma for the population standard deviation, S for the sample standard deviation. Okay? Any questions on that before we keep moving? Okay. So how do we calculate the mean? So if you had to say how you calculate an average or a mean, I'm sure you guys have hopefully done this before. What would you like the easiest explanation you would say? If I have 5 numbers, what would I do to find the mean of those 5 numbers for the average? Yeah, right. Just add them up and divide by 5. And what you're really saying there, you probably already intuitively know it. I add all the numbers up and divide by the total number of numbers I have. Total number of numbers I have. If we wrote that out mathematically, I'm going to use this a little bit because it helps us to understand and think about the variance a little bit more later on. To find the population mean, this is called a summation sign. So all this summation sign means, start at the first observation, go to the last observation, and add up all the values that you see for this variable x, right? So take the first observation's number, add it to the second, add the third, add the fourth, all the way to the very last observation in that population data set. So we'll call capital N will be the total number in our population data set. Once I've added up all those numbers, divide by the total number of numbers in that data set. Right? Which is really what we had just said. Add up the numbers and divide by the number of numbers you added up. Okay? Now, the sample mean, it's the exact same thing, but just introducing some difference in notation here. Now, instead of going to the total number in the population data, we're just going to go to lowercase n, which represents the total number in your sample data set. Okay? But procedurally, right, there's no difference, right? You're adding the numbers up and divided by the total number of numbers in that data set. It's just one of them notates that it's sample data, the other is that it's population data. All right. So let's say, what if I wanted to find the mean birth weight in the United States? And I had this data set of every single birth ever recorded. What would I do? I'd go through, add up every single birth weight, and then after I added those all up, divide by however many births there were in the US in that data set. Okay? And I have this data set, or data set like this, I'll bring in, we'll play around with it throughout the semester. So I'm just kind of introducing it here now. We'll use this birth weight example. Okay? So let's think about how we do this. We'll walk through a few more examples. Like I said, this probably is like review maybe for some people, or it's not too hard, but just to kind of go through and talk about some things. So let's say I have this data set and it's got points scored here for some game, right? It could be basketball, boggle, it doesn't matter what it is. So I've got 7 games and these are the points scored. How do I find that population mean? I just go through 20 plus 35 plus 15, 18, all the way down here. Once I've added all those up, I'll divide by what? 7, right? That's 7 numbers. That's how many I've added up. So I'll divide by 7, about 23.86. Okay. Oops, sorry. So that shouldn't be too bad. I'm gonna sit down here for a second. So that's how we would find a mean. You could look at another example, right? And this might look similar to kind of a question I give you in the online quiz after class today. But I've got commuter time, right? And then the employee number, right? So I've got 7 employees. How would I find the mean? Just add these up and divide by the total number of observations, which is 7 again. Now, I'm going to show you something here. I did this. I'm going to change this real quick so I can make a point here. So let's say I gave you these as potential answers, right? Let's say I'm lazy and I don't want to add these numbers up, right, and divide by 7. I just want to guess. Well, I can actually make a more educated guess by getting rid of some of these that I know are wrong. Now, I just changed them, so you probably already know it's going to be C and D. But why, if I'm trying to find the mean, could C or D not be a possible answer?
Oh, because D is higher than the highest.
Yeah, so D can't be one because it's higher than the highest number, and C is lower than the lowest number. Remember, we're calculating a statistic that's supposed to tell us what value is kind of most of the data centered around. Well, if the data is centered around this value, it can't be a value that's outside of the range of possible, outside of the range that values we see for that variable. So here we know the mean has to be somewhere between the maximum and the minimum, somewhere between 20 and 90. So maybe even a question I might ask on that quiz would be something like, give you answers and say, which one of these without using the formula do you know can't be a possible value for the mean, right? And it's anything outside the range of that maximum and minimum value, okay? Now, if we go ahead and calculate this, so we add them all up, divide by 7, we get 45, right? So this is another example we can kind of look at and see how we would calculate a mean. But I wanted to use this to point out, you can sometimes, especially in these multiple choice questions, rule out some answers. And if I'm typing this in my calculator and I accidentally hit 4 instead of 7, I might end up with something that's really high, and I don't realize I made the mistake. But if I stop and think about what am I doing, I can quickly figure out I made a mistake, right? All right, so now we'll go to the median and the mode. So the mode is just going to be the value that we see recorded for that variable that happens the most or is recorded the most times. Or another way of saying this, what value is the most frequent value we see for that variable, right? So whatever has the highest frequency, that's going to be our mode. The median is going to be the value that exactly splits our data in half. So 50% of the observations will be above it, 50% would be below. So for example, if I had 9 observations, it would be the value such that there was 4 observations below it, 4 observations above it, and then it would be like that 9th observation, right? It exactly splits it in half. Now you might think the mean does the same thing, but I'll show you an example here in just a second why it's not necessarily the case, okay? Now it's easy if we have an odd number data set because we can always get really the process in which we would find the median. I would say, okay, cross off the highest value and the lowest value, then cross off the next highest and the next lowest value, and continue that process till I'm left with one number. That would end up being the exact middle number that splits the data in half. Now, if I have an odd number data set, it's fine. I'll end up with one number. But if I have an even number data set, if I cross off the last 2 numbers, I'm left with nothing. So what I'll do is whatever 2 numbers are left after that process that are exactly in the middle, I'll just take the average and find the mean of them, right? So if I have an odd number data set, it's just whatever number is left. If I have an even number data set, it's the mean of the 2 numbers that will be left. Okay? So that's not too bad. So let's say we have that same point score data. What would the mode be here? So remember, the mode is the number that happens the most times, or the value that's recorded the most in this data set. I think someone said 35, right? It's the only value that happens more than once here. It happens twice, and so it has the highest frequency, right? Or it occurs the most often. So we get 35 as our mode. What would the median be? Well, the process for the median, right, and it shows the answer here, but what we do is cross off the highest, cross off the lowest values in the data, cross off the next highest and next lowest, cross off the next highest and the next lowest, and once we're left with one number in this odd number data set, that will be our median. Notice if I look at 20, oops, there would be 1, 2, 3 observations above it and 1, 2, 3 observations below it. Exactly splits that data in half. Okay. I could do the same thing here with that commuting time data. Same process. Cross off the highest and the lowest. Or I could arrange them. Sometimes that makes it a little bit easier. If I arrange it from smallest to largest, I can quickly see here's 3 observations that are the lowest, 3 observations are the highest. The one I'm left with is 40, right? So you can cross it off in the actual data, or you can write it out smallest to largest and then look for that middle value. Whatever way is kind of easy. Now, obviously, with a higher number data set, this is going to take a lot of time to do this by hand, right? So I'll also show you on Wednesday how we would do this in Excel. It's pretty easy. It's a built-in function. Right? So one thing I want to go through now a little bit clunky, I apologize. So I should be frozen on Zoom for a second, but I should come back here quickly. And just to double check, you guys can still hear me on Zoom, right? I just got some weird thing that said you might not be able to. All right, perfect. So let's say I have this like really basic data set of 5 numbers. Right? What would the mean of these 5 numbers be? Well, I add them up, divide by the number of numbers I have, so I add all these up, get 30 over 5 or 6. Right? What's the median of this data set? Across the highest, lowest, highest, lowest. The median would also be 6. Okay? Make sure that was just a response to my question. Okay, perfect. So this is an example where the median and the mean and the median just happen to be the same value, right? And they happen to split it in, the mean actually splits the data in half too. But what if I had a slightly different data set that looked like this. Well, now when I find the mean, if I add these up and divide by the total number of numbers I have, my mean's 24. What's my median here? Still 6. Right? So the median is not influenced by extremely high or extremely low values. But the mean, especially in a small data set, is greatly influenced by it. Right? So I have a smaller data set, it may be beneficial to really look at that median as opposed to the mean. Because if we want a measure of central tendency, where is most of the data centered around? Well, in this data set, most of the data is still centered around a smaller value, not near 24, right? These data sets aren't much different other than one observation. So imagine I had like, instead of just 5, I had like 10, and first 9 numbers are all the same. If that last one is a lot bigger, well, that mean just becomes a little bit less reliable about where that central tendency of the data actually is, right? So sometimes, we'll want to look at the median as opposed to the mean for that measure of central tendency a little bit more. Okay. Any questions on that? I think it kind of makes a nice, hopefully, quick example that gets that point across. So let's go back to the camera. So go back to the screen. All right. So where are we at in time? All right, got a little bit of time. So last thing I want to do is, I actually thought we wouldn't get to this, but we'll end on this today, and we'll kind of pick up with talking about measures of dispersion or variation on Wednesday. So this median sometimes can be better, and I'm going to relate this to the distributions I was talking about earlier in class. Okay. So if we had a nice normal distribution, what ends up being true, like that small data set that I showed you an example of, what ends up being true is the mean is equal to the median is equal to the mode. Right? Now with a small 5 observation data set, we couldn't really see a mode there, but if we had a really large data set, this would hold. Right? Now, if I have extremely high values in the data set instead, what is going to happen is, remember, this distribution, this line, it really is like our histogram. It's really just like a bunch of really small rectangles, right? If I made the bins really small, so I'm just drawing a line that would kind of hit the tops of those rectangles. If I had a lot of really high values, well, then I'm going to have some extremely high values in the data set, so the values further from the mean start to become more likely. Well, with these really high values, we just saw when I put that 100 in that data set earlier, it pulled the mean way, way up. So when I have high values, the mean gets pulled up higher than the median does, or the mean is to the right of the median, or greater than the median. So when the mean is greater than the median, or to the right of the median, we have a right skewed distribution. Now, it also happens to always have a long right tail as well, but the real reasoning there is, even if I couldn't see this distribution, like let's say I didn't show you this graph, and I just told you, I have a data set, the mean is 50, and the median is 30. Well, the median is less than the mean, or the mean is to the right of the median, I would know I have a right skewed distribution. Same kind of thing. If I have really, really small values, maybe a lot of values really close to 0, it's going to pull the mean down or to the left, make it smaller, but it won't influence the median near as much. So if my mean is to the left of my median, well, now I know I have less skewed data, or a less skewed variable, less skewed distribution for that variable. So even if I can't see these distributions, and all I have are the mean and the median from them, I automatically know if the mean is to the left of the median, it's less skewed. If the mean is to the right or greater than the median, it's right skewed. Okay? So that's really where that naming comes from. And we could get it without even seeing the picture of the distribution, just looking at those statistics of the mean and the median. Okay? see, any questions on that or? Oops. The other thing I want to mention here as well, and you kind of see this visually. Remember, the mode is just the most frequent outcome. So if I have the distribution, remember what's on the y-axis here, it's really representing frequencies. So wherever the highest point in that distribution is, that's the most frequent outcome, which is the mode, right? The thing that happens the most, okay? So yeah, so that kind of gives a nice little synopsis there. Pretty good point to end on. We'll start off on Wednesday talking about ranges, variances, standard deviations. We'll do a little bit of just kind of work in Excel. But what I am going to get posted today is your first Excel assignment. So it'll be very similar. The bulk of the assignment will be what we worked through Friday and today. The stuff that we'll cover Wednesday, there may be a couple questions at the end of the assignment that are similar to that, but you should be able to work through 90% of the assignment based off what we've already done, okay? Excuse me. That completed version of the slide, you'll have that template there to look at as well, even if you missed a couple things as we were walking through it in class. The complete version is up there on Canvas as well. So if I were you, when you work on that first Excel assignment, have the Excel assignment pulled up and like the one that we worked through in class. Like use it as a template for what to do. Okay. Now, just because we did things in class doesn't mean you have to do the assignment, right? I think one time I had let me see if I can show you here. So like the one we worked through in class, right? I added in this additional column. If you look at the completed one, because it only has the cumulative relative frequencies here. And I added in the percent frequency in the completed file. So you can have this open and use it as a good template, but on the homework assignment, I might not ask you for the percent frequency, right? So it doesn't mean you have to do it, but I might ask you for the relative frequency. And so this is a good template for how to do that, right? So just because we did it, I'm saying use this as a template, you won't have to do every single thing that's in here potentially on the assignment, okay? So I'll get that posted today, pretty quickly following class. If you have any questions as you're working through that, let me know. If you want to set up kind of a Zoom for office during my office hours, I think it'd be kind of easy because like you can share your screen with me. I actually started thinking about this the other day. It's probably for the help on the Excel files. It's probably easier for us to do a Zoom call, even if we were sitting next to each other, just so I can quickly see what's on your screen and you can see what's, I can kind of show you maybe how to change it on mine. So I actually think for help with these Excel files, homeworks, the Zoom meeting will actually be really useful if you need some help with those to meet that way instead. Okay. All right. Any questions before I let you guys get out of here? Like I said, if I'll try to get some type of cross-reference with who's quarantined, so that if you do want to show up on a different day, maybe kind of moving forward we can get it so it's not the way that I have it right now. Or if I know there's going to be vacancies on one of the days, if you send me an email, I can let you know that you could show up that day, and then I'll just have you like write in where you sat, so for the contact tracing. Yep. Yeah, let's see. So this?
Yeah.
Yeah. So, oops. Move this. So group one, you use me in terms of how this is arranged.
Yeah.
Oh yeah. So this is like the front. So if I'm looking at it.
It's not Friday anymore.
Oh, so group one this week would meet Monday and Friday. Then group two meets Wednesday. Next week, group two will meet Monday and Friday. Group one would meet Wednesday, right? Because it's the only way I can, we just didn't have a small enough number where I can get everyone to be able to go to 2 each week, right? Like I said, maybe because of how many people are quarantined right now, if I can cross-reference it and make sure that everyone's good, I can change that moving forward. But the problem is that changes week to week. People who are quarantined right now want to be able to show up in person eventually. So for now, we're going to kind of use this as a template. But yeah, you guys are. I didn't count the number here. I'm going to stop the recording.